All right, going out with a bang. Nuclear power. So, for a very, very, very long time, the old Greek guy who discovered or decided that atoms are the smallest particle thought that they were indivisible, they couldn't be taken apart, thought they were the smallest things, but actually in the early 20th century, 1900s, scientists learned that you can actually cut an atom apart and you can even fuse them back together. So, we talked about like stable and unstable atoms. These ones that are divisible are not stable. Okay? Protons and neutrons are nucleons because they are in the nucleus. We talked about this strong nuclear force holds them together. And then electromagnetic repulsion or electromagnetic energy is what pushes them apart. So, without the neutrons, we wouldn't have this strong nuclear force. They do this without repelling the protons, since they're not opposites, they don't push each other away. And then since the strong nuclear force only works over short distances, your very, very tiny nucleus, eventually there are too many protons and the repulsion wins. So, the strong nuclear force holds them together as best it can, but if you get too many neutrons, they hate each other and are pushing apart, and eventually they will explode. Not really explode, but they'll move away from each other. If you get over 83, so this is the limit. Strong nuclear force works up until 83 protons. And then, if you get to that level, your nucleus will undergo radioactive decay. So that's what makes these fly apart. So we've talked about a lot what these numbers mean. Your atomic mass comes from what pieces of the atom? Protons and neutrons together add up to make the mass. And then your atomic number is your number of protons. So we did this a couple weeks ago for the isotope notation. We're not going to talk more about that too much. But once that atomic number on the bottom, if it got to 83, this would not be held together anymore. And the kinds of radiation you can have, there are 3 types. Got these on my desk over here. All right, so we've got those Greek letters. Alpha is your first one. Beta is your second one. And we also have gamma. So these are the types of radiation, radioactive decay that can happen if that strong nuclear force breaks. Any questions so far? All right. This explains those types of... Okay, I don't have enough room. We'll look at this and then we'll scroll down. Alpha decay is a low energy particle. Helium has 2 protons and 2 neutrons. So they're smaller? I don't know. These can be stopped pretty easily. You can stop them with anything as thin as paper. When this alpha decay happens, the atomic number is -2. So it loses 2 protons. And the mass number is -4, which means it's also going to lose 2 neutrons. And then they've given this example. Is uranium? Pretty sure, right? Somebody look at your periodic table. So if we have uranium-238, it goes through alpha decay and becomes whatever TH is and releases an alpha particle. That's what this little thorium. Thorium sounds good to me. So we end up with thorium and then an alpha particle, this little Greek letter, kind of looks like a fishy A, is left over. Color. Kind of. It's missing its circle. All right. And then we've got beta decay. So a neutron splits into a proton and an electron. Before this, I had no idea that was a thing. Did you know neutrons could actually turn into protons? Me neither. Yeah. Well, good for you.
Why were you chemistry class?
Me too, a long time ago. I don't think we talked about this.
I took it in 2020, but
So, beta decay is a little, not heavier, stronger. You need like closer wood to stop it. More force, that's a good explanation, thanks Dylan. If beta decay happens, your atomic number is going to change +1. So if your atomic number changes, what part changes? What tells you, the atomic number tells you what?
how many atoms are in the nucleus?
Protons. How many protons are in the atom?
I met protons.
Great, glad to hear. All right, so your protons, your atomic number will get +1. Nothing will happen to your mass. All right? So carbon 14, if it undergoes beta decay, is going to become nitrogen 14 plus a beta particle. So this weird B is that Greek letter. And so when this decays, it changes to nitrogen and beta. Weird. And then gamma is a little different. It's going to produce gamma rays instead of just decay. It's very high energy and really strong. You need lead or a lot of concrete. It's very dangerous when that, like if you've read about or watched Chernobyl, when that power plant erupted, it kills a lot of stuff, right? It doesn't change the atomic, like, it still has the same number of protons and stuff, but it releases gamma rays.
There's this Japanese guy that was exposed to so much radiation, his cells were dying and not reproducing while he was still alive.
Yeah.
They basically alive.
Yeah, it's terrible.
And he was kept alive for testing.
Oh, how rude. Okay, so pull out your periodic table because you need it. This first box says fluorine 20 undergoes beta decay. What happens in beta? Atomic number what? +1. And your atomic number is protons. So if fluorine is what we're starting with, but we're going to add 1 proton, what is it going to become? So, yes. What number is fluorine? 20. So we're going to add 1 more proton, so what number is it going to become? 21 is what? Look on your periodic table. What atom is it? What element is it?
NBO.
No.
That's what fluorine's number is, right?
Remember the little number is? What? No. Oh. But we're not, 20 is not fluorine's atomic number. What's fluorine's atomic number?
Oh,
9. So we're adding 1 proton to that.
10.
10. Yeah.
This is your
20 is the mass number, yes. So So fluorine has 9 protons. It's going to become 10 protons, which is, you already said, neon. So be careful. Remember, those isotopes end with their mass, not their atomic number. Does that make sense, though? Okay. It's asking about next sulfur. Sulfur 34 undergoes alpha decay. What happens in alpha? -2 protons. So what is sulfur's atomic number? It is 16. Okay, so -2 will become, and what has an atomic number of 14? Silicon. Silicon. Does that make sense? Yeah. Okay. Questions there? This next part looks super ridiculous. Easy? Okay. So you just have to look and decide. Let me get my own periodic table. What is happening? Is it alpha or beta? And you decide that by what does it become. So if we look, they start here with uranium, 92. It's going to lose 2 because it goes from 92 to 90. Okay, alpha, it says to put on each arrow, put either the alpha sign or the beta sign. So Tyler said this is alpha. Alpha looks like a little Jesus fish on people's bumpers. If the number goes down, it's alpha. Okay, so let's make a note up here. Alpha, proton number goes down. All right. What about for beta? Up by 1. So yes, you're right. It's easy, but it looks ridiculous. Okay. All right, so for the next one, we have 90, but then 91. So that'll be beta. Let's see if I can make this fancy B. All right. Then 91 becomes 92. Beta. Up by 1. All right. The next one we're going back down by 2, so that'll be alpha. 90 is going to go to 88. That's down again, so it's another alpha. Make sure we put it up here. All right. Down again. Alpha. All right, then 86 goes to 84. Another alpha. Another one, 84 to 82. Man. And then 82 becomes 83. So up 1 is back to beta. 83 to 84. Ah! Hold on. Where are you? The after BI is a beta. And then down by 2. 84 to 82. Alpha. All right. Beta. And then we're going going from 83 up to 84. Also beta. Where am I? 84 down to 82 is another alpha. Sure, it was easy, but it looks crazy. So, any questions? Alpha drops, beta gains. Good. Okay, go ahead and turn the page. Guess what? What?
I know. He said I have 5 billion atoms in my body.
Okay. This is on your test for sure. So the last thing here is fission versus fusion. Power plants use fission. Do you know what they're doing in power plants? What is nuclear fission? What does that mean? Yeah. Whatever they're doing, whatever they're using, they're breaking it down. Fission breaks things apart, splits them. Splitting atoms is fission, okay? The other type of nuclear reaction you can have is fusion. What happens if you fuse things together? Yeah. Yeah. You combine something, and it becomes something new. Mom. So, our power plants use fission. The sun uses fusion. Have any of you heard of They Might Be Giants? They're a band, and they sing about science. They have a song about the sun, and they say, it's a gigantic nuclear furnace where hydrogen is built into helium at a temperature of millions of degrees. So that is fusion. Hydrogen is built into helium in the sun. Yeah. It's a big furnace that turns hydrogen into helium. It is. Okay, so let's talk about these processes. Fission takes large atoms and splits them apart. Tyler mentioned plutonium, but uranium is one of these things. We have a lot of uranium plants. Yeah. Uranium, also dangerous, so be careful. If you take 1 pound of completely fissioned uranium, you're going to get 6,000 barrels of oil out of that. So they produce a lot of energy, these fission processes, or 1,000 tons of high-quality coal. So like one little thing of uranium is going to give you a big reaction with a lot left over. It could also kill you. It also creates waste products like toxic radioactive waste that won't go away for billions of years. Yes, that's why power plants are like really secure. Sometimes under the ground, under domes, because they are dangerous. Yes, you're right. And they have a lot of toxic waste. Yes. So, they make a lot of stuff really fast, but there's a price to pay there. On the other hand, fusion combines atoms together. So, two hydrogen atoms in the sun are fused to make helium. 1 square kilometer of seawater. So you are fusing things together in welding, yes. It's not nuclear fusion, but it is. It is. 1 cubic kilometer of seawater is more energy than all the known fossil fuels in the world. That is a great question. Why don't we do this? Perfectly safe, like helium is safe. We have tons of balloons. We could just make more. Okay, you shouldn't do that, but helium as a byproduct is not going to destroy the earth, right? It's not going to kill you. So, yes, why aren't we using nuclear fusion? People are stupid. Well, yeah. This is why. That is exactly why. There is not enough funding for scientists to figure out how to do this fusion stuff. They're working on it. Takes time, though. And so far, they haven't successfully controlled fusion. It's really hard, apparently. So they're working on it. But, yes, we should invest more into fusion research because it's way safer than fission. I am sure a scientist has accidentally caused themselves bodily harm trying to figure out fusion or fission or both. All right, and then in the bottom of this page, just a couple things. Half-life, these vocab words. The half-life is the time it takes half of a radioactive substance to decay. So carbon-14 has a half-life of 5,730 years. So that's only half of it would be reduced after that long. So unfortunately, they never decay to zero. They just get tinier and tinier, but they're still there. They use half-life, scientists use half-life to carbon date things. So like when they tell you, oh, this dinosaur is million years old, they've used carbon dating, finding how much carbon is left in that thing to decide how long it's been there. So, pretty crazy. And then these fission that causes a chain reaction. It's going to keep producing another split and another split and another split. Like dominoes. All right, so very last thing. Let's go through these and match the matches. All right. What is an alpha particle? Yep, alpha particles are what? Yep, an alpha particle happens when you add 2 protons and 2 neutrons to a atom. So it's a D there. Okay. What about a gamma ray? E. Yeah, they are dangerous. They can cause damage. Beta particles. You said B? They add 1 proton. It's when a neutron breaks into 1 proton and 1 electron. What does it mean if something is radioactive? Yeah, it's going to emit energy or a kind of particle. And then uranium is it's what we use in our nuclear reactors. All right. Then the ones we just talked about, a chain reaction is C. Yep, they just keep happening over and over. What is fission? It's which one? B. Fission is splitting things. Laura, let's go one at a time, please. Fission is toxic. What about fusion? A, combining things. Our sun, which is a star, does this. Half-life? E, how long for half of something to decay. And then carbon dating, D, uses half-life to find how old things are. All right, tomorrow we're going to do review